Okay, let us do the problem number 3.12. So this is related to calculation of electric field. So this question says a thin non-conducting ring of radius r has a linear charge density lambda is equals to lambda naught cos theta, where lambda naught is a constant and theta is the azimuth angle. So I have a ring. So let me say, so I can place this ring here because I have to find in the z direction. So let us plug this ring something like this. So this is my ring. Now this says linear charge density on this ring lambda, that is given by lambda naught cos theta, where theta is the angle of azimuth. First part of the question says find the magnitude of electric field strength on the axis of a ring at a distance x from the center. So what we have to do is we have to find electric field. So let us say this is the center of this ring. I have to find, so this is the axis of, so let me write something like this. I think you can understand. So this is the axis of ring. I have plotted this as along the z direction. So this is the axis of this ring. I have to find electric field somewhere here. So this is a point P. I have to find electric field at point P. So let us do this one first. I have set my x-axis in this direction. So this is my x-axis. And let us say this is my y-axis. And this is my z-axis. So this side I have z-axis. What I have to do is we have to find electric field at point P. Now let us first draw the charge distribution. So you see in this problem charge distribution lambda naught cos phi. So this is my xy. If I look from the top, I will see this ring, the ring is xy in plane. So I can show the same thing here. If I look from the top, this ring will look something like this. Now this is my x-axis and this is my y-axis. So this is the top view. If you look from the top, so this is the top view. Are you getting? Let us consider any point here on the ring, or let us call this point as A, and this makes an angle theta. So charge density at point A will be lambda naught cos theta. You see when theta is 0 to 90, the sign of lambda is positive. When theta is 90 to 180, again sign is negative. So in the first quadrant is positive, second quadrant negative, third quadrant negative, because cos theta changes its sign. So first quadrant positive, second quadrant negative. So let me put this here. So now I can show sign. So on this first quadrant it is positive, fourth quadrant again positive, and second and third quadrant negative. And this charge is of course not uniformly distributed because lambda varies with cos theta. So this charge is not uniformly distributed. When theta is 0 degree, charge distribution is high. When theta is 90 degree, charge distribution is almost 0. You see here, when theta is 0, lambda is lambda naught. When theta is 90, so lambda is 0. So you see, initially have a high charge density in this region, and this decreases, and finally here it will be 0. So you see, I can show something like this. So if I show only in the first quadrant, you will have same thing. You will have here high charge density, and then charge density will decrease, and then there will be 0 charge density, almost 0 charge density. So in this region you will have high charge density decreases. So along this charge density decreases. Now let us say what is the coordinate of point A. So my target is to find coordinate of point A. So this is r. So let us say radius of this ring is r. So the x-axis, this is r cos theta, and the y-axis, this is r sin theta. So this is r cos theta I, and then r sin theta z. Simple. So this is the coordinate of my point A. Now what I have to do is, I have to find, so let us say if I consider a point r at this point A, and then again I consider a d theta. So a theta, let us see same thing here. So this is my point A, and this diagram now I will show. Now this is angle theta, and I can consider a small angle d theta, and due to this there will be a small portion. Now if I see due to this there will be electric field at P. Are you getting or not? So this electric field will be directed along this line. So this is a vector. So electric field will be a vector. Are you getting? Now we can calculate this vector. So let us write the direction of electric field will be in the direction of AZ. So direction of electric field will be in AZ. So let us say write vector AZ. So vector AZ is nothing but vector Z minus vector A. That is the coordinate of Z minus coordinate of A. Now coordinate of Z is what? So this is 0, 0, 0. Now I am going along the Z direction, so x and y will remain 0. So the coordinate of P is 0, 0, x, because question says this distance is x. So now I can have vector AZ, that is coordinate of Z, 0i plus 0z plus 0k, not 0k, xk, minus, so this is the coordinate of Z minus coordinate of A, that is 0 r cos theta I plus r sin theta z plus 0k. So you see what we have. So vector AZ is nothing but xk minus r cos theta I minus r sin theta z. So this is my vector AZ. Now I can write electric field at P in this form, so that is dq by 4 pi epsilon naught rq into vector r. So I can write electric field in this way. Now dq is what? dq is nothing but lambda into r d theta. So lambda into r d theta into r. So vector r is nothing but this vector AZ. So vector AZ is nothing but this, we have already written. So xk minus r cos theta I minus r sin theta z, and this divided by 4 pi epsilon naught rq. So we will have 4 pi epsilon naught. And what is this rq? So this length is x, this length is a, so this length is x square plus a square under root. You see, are you getting or not? You can see from here also. So we will have x square plus r square cos square theta plus r square sin square theta under root. That the magnitude of this vector is x square plus a square under root. So this means rq, that is x square plus a square to the power 3 by 2. Because the length will be under root x square plus a square, then we have to cube. So we will get this term. Now I know the electric field component, x component, y component and z component. Now we can do simple integration. So copy this one and we'll discuss the next. So let us say x component of electric field I will have. So this is r cos theta I, so minus lambda r cos theta d theta I am taking only x component, so r cos theta will come here. This divided by 4 pi epsilon naught x square plus a square raised to the power 3 by 2. X and a are constant, this is not variable, only theta is variable. Now you see, lambda in this question is given by lambda naught cos theta. So this lambda, if I plug lambda naught cos theta, so cos theta into cos theta, that is cos square theta, and you will have r also into d theta. This divided by x square plus a square raised to the power 3 by 2, and then we will also have 4 pi epsilon naught. So let us say electric field, x component of electric field is lambda naught r and 4 pi epsilon naught, and this is not a square, basically this is x square plus r square, because I have taken radius of the ring is r, so everywhere in place of a I have to plug r, so this is the mistake. So in place of a you plug r, because radius of ring is r, capital R. Are you getting? So we will have x square plus r square raised to the power 3 by 2, and then integration we will have cos square theta d theta, and this will go from 0 to 2 pi, because if I cover this ring I have to integrate from 0 to 2 pi. So let us copy this one. Basically there is one more mistake. You see, if I write the x component lambda r d theta into r cos theta, so this r into r, it will become r square. So everywhere I have to write r square. So this is r square. Here also I will have r square. Now I have to do integration of cos square theta d theta 0 to 2 pi. So let me do this integration. So let us leave this one. Now we are doing some integration here. So integration of 0 to 2 pi cos square theta d theta, and this can be written as 0 to 2 pi cos square theta can be written as 1 plus cos 2 theta, this divided by 2. Now this is can be written into 2 integration. Are you getting on? This is mathematics, you have to do yourself. So 1 by 2 0 to 2 pi d theta plus 0 to 2 pi cos 2 theta d theta. Are you getting? Now if you see, this value will be 1 by 2 and d theta is 2 pi, d theta is theta and theta is 0 to 2 pi, and this is cos theta is sin 2 theta, and this divided by 2 sin 2 theta by 2, and this is 0 to 2 pi. At 2 pi sin is 0 and 0 also 0, so this is simply pi. Are you getting or not? So if I plug this value in this integration, so this will be finally, you can do yourself, minus lambda r square into pi divided by 4 pi epsilon naught x square plus r square raised to the power 3 by 2. So the final electric field we will have, so pi goes out, so we will have x component of electric field in this case, that is lambda r square by 4 epsilon naught x square plus r square raised to the power 3 by 2. Are you getting or not? You can similarly find E by and Ez, and finding E by Ez is very easy. So you see, you can find E by and Ez. I can remove this space. So let us say, come here. If I write E by and Ez, I have to use this expression. So let us say Ez, k term. So I have to write, that is written in the form of k. So Ez will be lambda r d theta, and this lambda I have already written, that is lambda naught cos theta. In this space I have not written. So this is lambda naught cos theta. You see, when I was doing ex, that is lambda, I have plugged the value of lambda naught here, and everywhere we will have lambda naught. So this is not lambda, this is lambda naught. Here also we will have lambda naught. Are you getting? So everywhere we will have lambda naught. So this is lambda naught. Are you getting or not? So if I plug the value of lambda naught, I can have Ez lambda naught cos theta. So r cos theta into x, and this divided by 4 pi epsilon naught x square plus r square raised to the power 3 by 2. This is Ez, and I have to do integration for Ez x lambda naught r, and this all are constant. Cos theta d theta, and this is 0 to 2 pi, and integration of cos theta is sin theta. Sin theta is 0 at 2 pi as well as 0, so this is Ez will come out to be 0. Are you getting? So if you do this integration, it will come out to be 0. Similarly, you can find E by also, and E by again it will be 0. So let us try to visualize. E by will be lambda r d theta, so lambda into r into d theta, and then minus r sin theta z, so that is minus r sin theta, so r square sin theta, and this divided by the denominator we have same term 4 pi epsilon naught is r square plus x square raised to the power 3 by 2. Are you getting? And if I plug lambda is lambda naught cos theta, so this becomes minus lambda naught r square, and sin theta cos theta I can write sin 2 theta by 2. So sin 2 theta by 2, so 2 comes here, so you will have 8 pi epsilon naught r square plus x square raised to the power 3 by 2 into d theta. I have to integrate this from 0 to 2 pi. Are you getting or not? And our integration of sin 2 theta will be cos theta. Cos theta is 0 at 2 pi, and cos theta is 1 at 2 pi. Cos theta is 1 also at 0, so this integration will again 0. You can check yourself. So this integration will be 0. So now I can say Ex, you have already calculated lambda naught r square. You check your copy, by 4 epsilon naught r square plus x square raised to the power 3 by 2, and E by and Ez are basically 0. Are you getting? So this is basically minus. In case of Ex you have a minus, and you check here. So this is minus, so I have to plug here minus also. So this is minus lambda naught r square. You can check your copy. So this is E by and Ez are 0 respectively. So you see resultant electric field will be directed along the minus x-axis. So you see, if we have this figure, the first figure, electric field, so this is my x-axis, so these are the positive quadrant. Electric field will be directed here along the negative direction of x-axis. So this is the direction of resultant electric field, because E by and Ez 0. So if you put a charge here, this will go in this direction. Are you getting? Now the B part of the question, that is easy, that also asks what is the electric field at when x is equals to 0. So that is the center of ring. So you see, what is the electric field you will have. So this part asks what is the electric field you will have at 0, 0, 0. So in this case, you put simply x is equals to 0, you will get the electric field. So now I know variation of with x. If I plug x is equals to 0, so electric field will have, only x component will have, z and y is 0. So minus lambda naught r square, 4 epsilon naught, and r to the power 3 by 2, so simply r q. So this goes, so you will have minus lambda naught by 4 epsilon naught r. Question also says obtain the expression when x is much greater than r. So in this case, what you will have, you can neglect r, so you will have x square raised to the power 3 by 2, so this is simply x cube. So in that case, electric field x component, only x component will have, Ex is basically resultant electric field, that is E will be minus lambda naught r square, and this divided by, So we will have 4 epsilon naught, and x is a very high value. R can be neglected, so this is x to the power 3 by 2, so this is simply x cube. Do you understand or not? You see what I am doing, can be neglected with respect to x, so x square here is equals to x square plus r square is equals to simply x square. So x square is to the power 3 by 2, that is x cube. Are you getting? So you will have this value. So this is the electric field. You see, this is very obvious that electric field should lie only in the negative direction of x-axis. You can verify yourself. So if you see, if you have a ring something like this, and now if you want to find electric field at point P, now so let us say half of the ring is positively charged and half of the ring is negatively charged. Now this part of the ring will basically push this positive charge this side. This means the electric field direction will be this side. Now symmetrically, if you take charge this side, it will basically attract this side. So you see the electric field component this side and this side will get cancelled, but electric field component this side will get doubled. So you see, if you choose your x-axis in this direction, the electric field will always be minus x direction. So you can verify your result, that is electric field will only survive in minus x direction, and that's we are getting the result after doing the mathematical calculation. Are you getting? So you see, by just this picture one can say electric field will have only x component, z component is 0, and similarly you can see y component will also be 0, because in this case this is only in one plane. So y component will, there is no y component for this. Even if you consider some charges here and here, in that case also you will find the y component gets cancelled out. Of course, at least one thing is clear, that there will be no z component, because this and this cancels out. And y component and z component, if you have some problem, you can verify using the mathematics. We'll discuss the next problem.